A quick explanation of how security policies work with GitLab Flow to help people in the security world understand a little bit more about how the security scanning and vulnerability management fits into the overall developer and deployment workflow of the DevOps lifecycle. Here we go. First off, we have the basis of GitLab Flow, which is this idea of trunk-based development. You always have a default branch. It is currently by default called main. It used to be called master. And so there are commits, which are changes to, in a project, this is for one project, to one or more files that are recorded in Git on the default branch. So there's a series of commits here shown in blue. Now, the way you work with GitLab and its other Git-based DevOps platforms is in merge requests. So you have a merge request for a feature or a change or a bug fix that's going into this project. And instead of those commits going onto the default branch, they go onto the merge request branch. So this is the basic workflow for using GitLab for software development. Now, the point at which the merge request is brought back into the default branch is called the merge. And that commit that happens right there when the merge happens is called the merge commit. Now, there are a lot of nuances here. I'm way oversimplifying it, but this gets you the basic point across. Now, obviously, this is kind of boring because I just did a couple of commits here and then another commit for the merge. That's kind of boring, but it gets more interesting when you have multiple merge requests happening at the same time, because then you have individual developers or sub-teams working on different features, different bugs, different changes, and they might have more than one commit. They might have many commits, even hundreds of commits in their merge request as they're working, and they can interact with each other, but they always interact via the default branch. So typically, merge request one here got finished, it got merged. And the developers of merge request two are going to either up merge or rebase into their merge request so that they get the latest changes and can continue before they do their merge. Once again, a lot of nuance, but this is the basic concept of merge requests. So then where does deployment happen? Deployment can happen from any commit on the default branch to any environment. Usually a sequence of environments are deployed from the default branch. So these are long-running environments like UAT, QA, and even prod. They're deployed from the commits that have been merged on the default branch. We also have a capability called review apps, which is environments associated with merge requests. But for right now, we're just going to think about these main environments that you use throughout your organization. Now, notice these environments don't really need their own branches, though that's a common strategy to have separate branches for these. And actually, for a while, it was promoted in the Git community to have separate branches for each deployment environment. But in fact, with GitLab, we recommend have the commit be the focus of the deployment, and we keep track using GitLab environments and deployments of exactly which commit, because they're tagged, is deployed in which environment, and have a sequence of deployments throughout the environments. Now, obviously, you don't want to automate deployment to prod. Well, in most cases, sometimes you do want to automate deployment to prod, but many organizations don't want to automate deployment to prod. And so you can make those deployment steps manual. I've added decide here because you're making the decision to deploy to prod. So in this particular model, this commit has been deployed automatically to UAT and QA, and then a decision is made to commit it to prod after it's been checked out in QA. And obviously, you could decide not to commit to prod. You could then deploy from a later commit, whatever the process is that's appropriate for the organization. But we haven't talked about security scanning. How does security scanning fit into this? Well, using scan execution policies, essentially, it fits in everywhere. So there are really very different ways of thinking of the scanning. There's the scanning in the merge requests themselves. So every commit in the merge request is scanned, and the scans on the default branch. Every commit on the default branch is scanned. Typically, these commits on the default branch are only merge commits. It is possible to have other commits on the default branch, but typically these are merge commits. And even though this merge request has been scanned, you still want to scan the commit after it's been merged onto the default branch to make absolutely certain that merged product is completely free of any vulnerabilities before you do any deployments. So, and what's great about scanning inside the merge request is the developers actively working on these merge requests can see the results of those scans and in many cases remediate vulnerabilities immediately while they're still working in that same code base. A lot of times a developer will see a vulnerability from a SAST scan, for example, and they'll say, oh yeah, that's right, good point. Make the quick change, do another commit in the merge request, and see the scans pass. So scanning, this is what we call shift left. Scanning in the merge request is the way of finding those vulnerabilities early. I should add that a finely tuned, well-oiled development organization is going to be not just doing scans. They're also doing unit tests. They're also running integration tests. They're also running style checkers, code quality checks, code coverage, all kinds of other information that helps them improve the quality of their code. So the scanning is one of several different types of automated processes that happen on every commit within the merge requests. And the platform for that automation is all GitLab CI/CD. Okay, but so that's scan execution policies, but then how do we say, hey, if there's a vulnerability, we don't want that. We want to prevent change from happening with the vulnerabilities there. Now, the thing that we found is that usually security scanners find vulnerabilities that need to be looked at and examined before you really want them to block further development. Because keep in mind, the scan here on the default branch is also allowing this commit to be used by another team. So in addition to blocking deployment, if you were blocking on this scan, you'd be blocking that team's ability to actually use that code. And you don't necessarily want to block development on the results of security scans because there can be such a variety in the results that you're getting. And so what we do then is we call on merge request approval policies. So merge request approval policies say the merge request requires approval before it can be merged. And that approval, there are a broad set of rules as to who has to approve. And that approval might already exist in your development organizations, that approval process, those rules, even outside of scanning. But with scanning, you have this specific kind of merge request approval policy that says if certain severities of vulnerability are found by certain scanners, hey, anything that's critical or high, for example, severity, then that merge request requires additional approval from specific people, typically the security team. So the approval step is the point where the security team can say, hey, I want to approve this before it gets merged. And keep in mind, your deployment step already has an approval in a sense. It's not the same, it's not a merge request approval, but that manual process that you can add in for deployments. And so I hope this helps to explain the differences between these different kinds of operations and how they fit into the overall GitLab flow. Thanks for watching.